Oke, pertama-tama saya mau minta maaf dulu ya, karena lalu itu saya eh, lalu kebetulan sedang berada di luar kota dan rupanya ada eh, sedikit ada miskomunikasi ya dengan Pak Dani ya, di mana eh, Pak Dani nggak jadi apa namanya masuk ke kelas gitu ya. Tadi saya minta tolong beliau untuk sementara briefly ya masuk ke kelas untuk menyampaikan beberapa hal ya, di kelas ya. Tapi ternyata ya ada miskomunikasi sedikit ya. Tapi alhamdulillah tugasnya sudah dikerjakan ya. Ini Clement nggak ada ya. Ya, mungkin kalau sementara belum ada kita pakai bahasa Indonesia dulu aja ya. Jadi eh, kan dulu ya sekali lagi mohon maaf dan terima kasih sudah bersabar ya dan apa namanya mensubmit ya tugas yang apa namanya yang diberikan ya. Dan ya tugas yang pertama ya hampir semua ya mensubmit. Jadi kalau tugas yang pertama dalam catatan saya dari dari 44 mahasiswa ya, jadi 43 mensubmit tugas yang esai yang pertama ya. Namun kalau kita lihat di tugas kedua ya, yang mestinya disubmit tadi malam ya, sampai tadi siang yang sekitar setengah 3 ya saya cek masih banyak sekali yang tidak mensubmit ya. Dari 44 mahasiswa hanya 29 yang mensubmit ya. Jadi apa namanya bisa dilihat yang saya warna abu-abu adalah mahasiswa yang tidak mensubmit tugasnya. Nah, jadi memang dalam mata kuliah ini banyak sekali tugas membaca ya. Ini karena apa namanya banyak tugas membaca ya tentu bukan sekedar membaca tetapi kemudian mensubmit apa namanya mensubmit tugasnya begitu tentunya ya. Jadi saya apa namanya saya harapkan Anda bisa eh, segera ya mensubmit ya walaupun dengan catatan nanti sudah terlambat ya catatannya. Yang pertama, yang kedua ya ini karena ada mendadak ya ada apa namanya kejadian di minggu lalu ya kuliah kita di apa namanya dijadikan online gitu ya. Ya, saya sendiri sih sebenarnya lebih lebih berharap kita bisa kuliah offline. Jadi minggu depan walaupun ada edaran juga untuk sekolah kuliah offline online minggu kita depan kita insya Allah akan ketemu offline aja ya. Jadi supaya apa namanya supaya diskusi ya bisa lebih 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 baik lah gitu ya ketimbang kita ketemu secara online semacam ini. Nah, jadi minggu depan kita insya Allah ketemu secara offline. Oke, itu yang sebagai catatan awal di kuliah kita. Dan nanti tolong dicek di Mas juga ada tugas berikutnya, gitu ya. Oke, nah pada kesempatan hari ini ya kita akan melanjutkan ya diskusi kita. Ya, sebenarnya ini mestinya biasanya saya sampaikan di minggu pertama gitu ya, tapi karena saya berhalangan hadir kemarin, ya saya menyampaikannya pada minggu ini. Jadi saya akan memulai dengan sesuatu eh, narasi ya bahwa kalau kita bicara di dunia geoteknik ini ya bahwa kita harus memperhatikan betul ya konstruk apa fase konstruksi. Ya, kita tidak cukup hanya belajar teori, belajar desain, ya, dan apa namanya belajar yang katakanlah aspek yang bisa di atas kertas, ya. Tapi kita harus juga memperhatikan aspek konstruksinya. Jadi itu narasi yang ingin saya garis bawahi, ya, narasi yang saya bangun. Bahwa kita ketika bicara di geoteknik, ya harus memperhatikan betul ya fase konstruksi ini. Ya, dan kalau kita apa namanya, eh, nah, kalau Anda lihat di emas ya, eh, saya sudah menuliskan bahwa kemudian mata kuliah ini isinya ada 3 bagian. Kita bicara case apa namanya konsepnya, ya. Kemudian kita bicara case studies, dan ketiga ya baru metode konstruksinya. Ya. Jadi dari beberapa para praktisi. Ya, jadi kuliah ini juga diisi oleh para praktisi untuk memberikan gambaran apa sih yang sebenarnya terjadi di lapangan. Ya, dengan demikian harapannya Anda mempunyai wawasan ya bukan hanya teori ya seperti yang sudah Anda pelajari dari Mektan dasar, Mektan, ya, rekayasa fondasi ya, tapi Anda juga mempunyai eh, wawasan ya pentingnya metode konstruksi ini. Ya. Jadi itu yang apa namanya narasi yang saya bangun. Ya, jadi makanya minggu lalu walaupun saya tidak hadir, saya membangun narasi itu ya melalui tugas membaca Anda ya dan apa namanya kalau Anda lihat ya di apa yang disampaikan Pak Osterberg ini ya Anda semua ya, ya hampir semua ya sudah membaca dari paper ini. Pak Osterberg ya menyebutkan ya kemudian memberikan contoh-contoh ya eh, kenapa ya ada kegagalan di dunia geoteknik ini. Ya, kalau kemudian kita melihat nomor 1, 2, dan 3, ya, memang itu lebih emfasisnya penekanannya adalah pada aspek sebelum konstruksi, ya. Misalnya inadequate surface subsurface exploration, ya. Itu adalah penyelidikan tanah yang kurang memadai, penyelidikan tanah yang kurang mendalam. Ya, kedua, failure to appreciate ya or understand the in situ behavior of soil. Ya, jadi dari subsurface exploration tadi ya, kemudian tapi kurang dalam juga kita memahami, mengapresiasi perilaku tanah kita. Ya, dan yang ketiga adalah careless in design details. Ya, apa namanya bahwa bahwa okay, there is climate here in the class. So I will start speaking in English. Yeah. So in number 3, yeah, we could see that the point is carelessness in design details. So in number 1 up to number 3, the emphasis is pre-construction, yeah, points. Yeah. Inadequate subsurface exploration, yeah, failure to appreciate or understand the in situ behavior of soil, and carelessness in design details. Those are pre-construction points. But if we look at the number 4, 5, 6, and 7, those are during construction points. And if we look at number 4, Yeah, errors in construction procedures. And that's definitely during construction. Yeah. Number 5, lack of sufficient and adequate supervision and inspection, definitely during construction. Yeah, 6, failure to recognize soil conditions different from those indicated or expected. It means that during construction, yeah, the behavior is different from what is expected, yeah, from the design concept or the design document. And the field people, yeah, failure to recognize the difference, yeah, between these two. It is during construction, but it's a bit more unclear. Okay, but 7, yeah, failure of communication, yeah, between field personnel and those responsible for design and construction. This is definitely not the technical content of geotechnical engineering. Yeah, but this point is very important as well. Okay, failure to communicate properly. Okay, so number 4 up to number 7, these points are during construction points. And number 7 is non-technical point of these points. Okay, so these are just to underline, yeah, the importance of construction phase, yeah, of geotechnical engineering structure. And on top of that, yeah, we need to communicate well, yeah, to make sure, yeah, to ensure that what is being done in the field is in line with what it is expected during the design. Okay. And yeah, most of you have done have read the paper, and you could see that the case number 7, the case that I asked you to read and write the summary. That that case number 7 explains that what is done in the design was not implemented in the field, and there was a step, yeah, that was not done by the contractor, and the end result is that the wall collapsed. Yeah? So that is to underline, yeah, the importance, yeah, of the construction phase, yeah, of geotechnical structure. And that is the exactly message what I'm trying to convey, yeah, when I ask you to read, yeah, the story, yeah, about the collapse of the 13-story building in Shanghai. Okay, what happened was not considered in the design, yeah, at all. Yeah, the contractors just put some fill materials, excavated materials behind the building, and whatever the mechanisms was, yeah, because there were some debates on the actual mechanism, that's a different story. But what happened in the field was not considered in the design, and the building collapsed, as you could see in the articles. And this article, this case, I mean, this case, yeah, underline, yeah, the importance of the construction phase, yeah, when we do the geotechnical structures, and to make sure that this kind of things would not happen in the future. But unfortunately, these things still happen. But again, this is to underline the importance of the construction phase. Okay. So I checked most of the submissions, and I'm quite happy actually about the submissions that those who submitted the essay, yeah, did quite a good job, yeah, to summarize what happened in this case history, yeah, the collapse of the 13-story building in Shanghai. Yeah, thank you very much for those who have submitted, yeah, the essay. And to highlight that, yeah, I'm gonna bring up this slide. Yeah, the slide in your PDF is in the later section, yeah, of the slide, but I'm just gonna go through some of this slide. And if you look at this, yeah, this is the study by Professor Sowers of Georgia Tech, yeah, in the United States. He collected 500 plus failures in civil engineering, including geotechnical engineering. Yeah. And what he found was very actually uh, to open our eyes about the problems that we actually face in construction industry. Yeah. Up to this day, actually. Yeah, although the paper was quite old, it's 1993, it's still relevant to our world, especially in Indonesia at this point. Yeah. And I highlighted the case, the percentage during construction. Yeah, if you look at the table down, the stage of project constructions, about 40% of the problem originated during construction. Okay, and about 60% originated from the design. Yeah, but quite a large part of the problem came up due to construction considerations. And the problem occurred partly about 40% occurred during the construction. So we could see that the construction phase plays an important part in the safety of our geotechnical construction. Okay, and the problems, the failures originating in design occurred 1/3 during construction. And the problems arising during construction originated from construction. And this is to highlight the importance of the construction phase of geotechnical structures. And just to bring up the point to highlight the narrative that we need to pay attention clearly about the construction phase of the geotechnical structures. Okay, so the following slides were are to explain more about this. So the first one is I'm gonna just bring up some very early speech of Carl von Terzaghi. Yeah, I think most of you, or it should be all of you, have heard about Carl Terzaghi. Yeah, he's called the father of soil mechanics. Yeah, or the father of geotechnical engineering. He wrote like the one of the pioneering book in soil mechanics. Yeah, soil mechanics in engineering practice. And in his speech, about almost 90 years ago, during the International Conference on Soil Mechanics and Foundation Engineering. By the way, that was the first conference. The next year in 2026, there will be the 21st conference. So 90 years ago, he brought up this issue, and still relevant to us even to this day. And in his speech, he highlighted some of the very fundamental things about geotechnical engineering. Okay, there are some points. I have uploaded the paper as well in MAS too. You could read the paper from the upload. And he highlighted the obvious ones actually. But this is something that we need to remind ourselves. One of the points he made was soils are made by nature, not by man. And the products of nature are always complex. This is obvious, but sometimes we never think about this. Soils are different from other materials in civil engineering. When we talk about concrete or when we talk about steel, those are man-made materials. What does that mean? It means that those materials are subjected to rigorous quality control. Okay, if the quality control don't pass, yeah, those materials are rejected. This is not the case when we are dealing with geotechnical engineering. What we face is geotechnical materials, the soils or the rocks are whatever the nature gives us. Okay, we cannot choose what kind of materials that we will face. We are given what we are given, and we have to deal with that. That's the major point that when we are dealing with soils, okay, we need to accept whatever it is in the field. We cannot choose, and we cannot uh, say, oh, this soil should behave like this. No, we just need to understand how the soil behaves. Yeah, that's exactly what Professor Osterberg mentioned in his paper. Yeah, to understand the behavior of the soil, whether the expected behavior is observed in the field or not. Yeah, those are the main points because again, soils are made by nature, not by man. Okay, and because of that, yeah, soil is very complex, never uniform. Even in one place, okay, or in one project, we can have different, completely different soil conditions. Okay? So we need to be very, very careful when we are dealing with geotechnical engineering, especially during constructions. Then during construction phase is when we actually discover that we are going to discover the actual soil conditions in its full condition. We do soil investigations, but soil investigations don't really show us the whole picture, the complete picture of the soil behavior. The complete picture of soil behavior would be revealed, yeah, during construction. That's why that's exactly what Professor Osterberg mentioned. Okay, and as I mentioned this now, the second one is its properties are too complicated, for rigorous theoretical treatment. So whatever we do in our calculations, yeah, those are just approximate, as mentioned in number 3. Yeah, even an approximate mathematical solution of some of the most common problems is extremely difficult. Yes, we do have very advanced numerical methods at this point. We have finite element, we have advanced software like Plaxis or Midas, whatever the softwares we have. But again, we have to understand those software, yeah, those mathematical solutions are just approximate. They cannot, yeah, replace the actual behavior that we need to observe in the field. Okay, so we have to put numerical methods in the right position. Those are just tools. Those are just tools to help us to understand. But what are given by those numerical methods are not the actual truths. The actual truths are, yeah, whatever we observe in the field. Okay, so this is very important. Yeah, this is a very classic points by Professor Trizagi, and this is something that we need to remember. Okay, soils are made by nature, yeah, not by human, not by man. So soils are complex and never uniform, yeah, and whatever numerical methods we have, those are just approximate, yeah, uh, so that we could get some idea what's going to happen in the field. Okay, that's exactly the sentence, yeah, put in red, yeah, the principal function of theory, yeah, consists in teaching us what and how to observe in the field. Yeah? So the numerical methods, whatever methods that are used by us, is to give ideas. So because the actual behavior would be observed in the field. Okay. So again, what we could observe in the field is during construction. So it is very important, yeah, to have thorough observations in the field, yeah, to make sure that what we expect in our design, yeah, is observed in the field. If the observation in the field is different from what we expect in the design, so we need to change the design, not the other way around. Okay, because again, the truth is in the field. So if the field behavior is different from what we expect in the design, we need to review, and maybe change the design, yeah, to match whatever we observe in the field. Okay. And again, there is different sentences just to highlight that, yeah, our inadequate knowledge, yeah, during the design, yeah, and we need to compare, yeah, the results of our simulations, our numerical analysis with those of direct measurements from the field. Again, we need to compare the design and the observation in the field. Again, the truth is in the field, not in our numerical model. And again, just to highlight, yeah, what Professor Terzaghi to emphasize, yeah, to emphasize is the measurement in the field. Okay. This is just to highlight my statement regarding the steel and the concrete, yeah, because those are man-made materials that we could have good quality control. Yeah. That is not the case when we are dealing with soils. This is another paper. Yeah, I already uploaded in the MAS 2 as well. Yeah, the paper by Professor John Berlin, yeah, of Imperial College London, and he wrote to me, it's very insightful, yeah, very important paper on what he has learned, yeah, during I think 40, 50 years of practice and teaching in geotechnical engineering. And he developed this so-called, yeah, geotechnical triangle, yeah, and this is to emphasize, yeah, there are three pillars. Yeah. Number one, ground profile. Yeah. You need to have good, yeah, soil investigations, and you need to understand the geology. We are in geotechnical engineering. Yeah, there's a geo part of geotechnical engineering that relates to geology. So you need to understand the geology as well. And after that, yeah, we could do lab tests, yeah, to get the observed behavior of soil, and we need to develop appropriate model, yeah, to get some ideas how it's gonna behave in the field. Okay, and after that, yeah, these three, yeah, including the field behavior, are creating this geotechnical triangle. And if you look at the middle part is so-called yeah, precedent, yeah, empiricism. Well, we know, yeah, experience. So these are together, yeah, need to be in one, are interlinked together to create what it's a good practice of geotechnical engineering. Okay, yeah, so-called geotechnical triangle. And just to highlight the geotechnical triangle, yeah, the first one is ground profile and genesis. Yeah, this is what he mentioned in this paper. I'm convinced that 9 times out of 10, the major design decisions can be made on the basis of good ground profile. Yes, similarly, 9 failures out of 10 result from a lack of knowledge, yeah, about the ground profile, yeah, including the groundwater conditions. Yeah, so again, the soils are, yeah, nature materials. Okay, and he mentioned about the observe and measure behavior of the soil, the field observations of behavior, including movements and groundwater flow. Yeah. that is part of the one pillar, yeah, and rigorous methodologies and advanced instrumentations. We're going to talk about instrumentation as well. So how we can observe what we have in the field, yeah, properly. Okay? So this is the first part. Yeah, we need to make sure that we understand the soil behavior, and the soil behavior is really in the field. Okay, and furthermore, yeah, I'm bringing up this paper. It is also in your package in MAS 2. Yeah, this is another paper by Professor Terzaghi as well, and you could see the title: Consultants, Clients, and Contractors. Yeah, from the title, you could see contractors, of course, is about the construction phase. Yeah. So this is really paper about how the design and the construction should be viewed. Okay. And I have some quotes. Yeah. And this is linked to what Professor Osterberg mentioned, yeah, in his paper. Yeah. In the, I think it's point number 7, communication. Okay. Communication. And this is what have been highlighted actually by Terzaghi. Yeah? And he mentioned, yeah, in the realm of earthwork and foundation engineering, yeah, the absence, yeah, of continuous and well-organized context, yeah, among the parties, yeah, objectionable and even disastrous. Yeah. So communications is very important, yeah, as highlighted by Professor Osterberg as well. And again, this paper was written in 58. So I don't know, about almost 70 years ago. And still, yeah, this is relevant to the geotechnical work to this point. And okay, why it is complicated? Yeah, we need to understand that each party has their own interest. Yeah, the contractor, yeah, is most likely his objective is how to perform, yeah, the work, yeah, as budgeted. Yeah. Most of the time, the contractors don't have or don't really care about the design, thinking about what the design thinking, yeah, by the consultants. Yeah. So can we expect the contractor to have a very rigorous treatment of the theoretical? Unlikely. Okay. How about the inspectors? Yeah? Or in our present time is typically called the construction management or the supervision as supervisors. And most of them actually just uh, don't have enough knowledge, yeah, to go into the what was highlighted by Professor Osterberg, by Professor Terzaghi. Yeah. They just do whatever they think, yeah, most important, and most likely those things are more on the administrative side of the constructions. Not too many inspectors or construction managements, yeah, really understand about the geotechnical conditions. So again, you are as to be civil engineers, graduated, yeah, from a good university, yeah, should understand the complexity, yeah, in the field, when we are dealing with this kind of work. Okay. And that the previous ones are the viewpoint of the contractor, the viewpoint of the construction management, and this is the viewpoint of the consultant, the design consultant. And the design consultant don't have any design consultants don't have any hand, yeah, on the what actually are done in the field. So they are in not a good position as well. Yeah. So as mentioned here, yeah, uh, the consultant has no control over what the construction management and the contractor chose to make out of the drawings and the specifications. Do the contractors and the construction management follow whatever has been written or drawn by the consultants? The consultants just don't know. And the consultants just don't know whether these parties are competent enough to understand the differences between the design assumptions and field conditions, as mentioned by Professor Terzaghi and Professor Mustaber. And sometimes still this is a problem what we are facing in the field. So my point is just to bring up to you that you need to aware this kind of conditions, and so that when you do actual construction work, wherever position you are in, you understand the complexity of this positions. Okay, and then sometimes the blame game comes in when something happens. As mentioned by Professor Terzaghi here, you could read it by yourself. Everybody blames the other parties. Okay, so does this still happen? Yes, this still happens in actual construction projects. And more, there is a paper by Professor Ralph Peck. If you open up the book by Terzaghi, that's typically by Professor Terzaghi and Peck. So Professor Peck was his student, Professor Terzaghi's student, and Professor Terzaghi's partner for a long time. And he mentioned again, the same thing. Failures occurred mostly because of lack of communication among parties in design and construction. So this point has been brought up over and over and over because this still happens to this day. Okay, and this is very important. Guidelines, regulations, or even the best specifications. Cannot. I think it should be cannot take the place of personal interactions between the designers and field forces. So the best documents cannot be replaced by good communications, good interactions. To highlight again, when we do constructions, we have to bring up the best of our communication skills to the project, so there is no points to miss when we are doing this. So I'm gonna continue with the paper by Professor Sowers. So the title says Human Factors in Civil and Geotechnical Engineering Failures. And this is the slide that I showed you previously, is to highlight the importance of the construction. And furthermore, actually, he mentioned about where or what goes wrong. And maybe these sentences, these statements are quite hard to read. I understand, because Professor Sowers, when he writes things, it's quite difficult to read. Okay, but basically, he proposed there are three major problems that lead to failure. Number one is absence. Number two is ignorance. Number three, rejection. And the absence, what is absence? Absence is about the data, about the knowledge or experience. And ignorance, it's about ignorance. Faulty decisions made by persons not having proper knowledge or understanding, failing to keep up with new developments, and blind reliance on analytical systems. Number three, as I mentioned to you, whatever yeah, software that you use, yeah, the software is just a tool. Yeah, the actual behavior is in the field. Okay, so if you insist, oh, this is what the numerical simulations tell us. So yeah, so you think that is the truth? Yeah, yeah, that would lead to so-called ignorance in Professor Sauer's terms. Okay, and the last one is rejection. Yeah, including communication problems. And if you look at this, yeah, the lack of knowledge, the lack of data is just about 12% of the problems leading to failure. And but ignorance, 33%, and rejection, the communications is the majority, yeah, the cause of construction failures, 55%. And that is what so-called human factors, yeah, according to Sowers. So you could see that almost, yeah, about 80 to 90% of the failures are related to human factors. Okay, so one thing that we have to learn about the technical things, about the geotechnical engineering, the soil mechanics, the lab, the models, the software. That is important as well. But don't forget about the human factors. Okay, that is very important because that would lead to failures, yeah, in the field. Okay, so just to highlight, yeah, we need to, so when we do reflection, we have to be really careful about when we compare the theory and the reality in the geotechnical engine context. As I mentioned to you, theory is one thing, yeah, but the reality is in the field, yeah, in the geotechnical engineering context. And again, you have to remember, geotechnical materials, soils are not man-made materials. We cannot control what is in the field. Yeah, we have to accept whatever it is, whatever in the field. Okay, and okay, we have to uh, think through, yeah, about the planning and the design and the construction, yeah, to make sure all these phases, yeah, are interlinked. We cannot just have a planning separated from the design separated from the construction. Yeah. We cannot have that in geotechnical engineering. And the last point is about communication. We have to make sure there is good communications among parties, yeah, to ensure that the geotechnical engineering work, yeah, to construct the geostructures are well communicated, and to make sure that everything would go as expected. Okay. To this point, is there any questions or things to discuss? Okay. I'm gonna continue. Yeah, if you have any questions later on, that would be okay as well. So I'm gonna continue with the second slide, and it is in must do as well. And this is to highlight, based on my experience, that are some issues, yeah, related design issues that we need to consider, yeah, in geotechnical engineering to ensure that the the design, the construction are in one, uh, in a coordinated, yeah, thing. Yeah, it's not just design whatever the design people just do whatever they think. appropriate, but that is not well communicated with the construction people. Okay, because again, we cannot have that in geotechnical engineering. Otherwise, we're going to have problems with that. Okay, so I'm going to give you some examples, real world examples. Uh, uh, the examples given by Professor Sowers, Professor Osterberg or Professor Terzaghi. Yeah, those are very good examples. But now I'm just gonna give you some real world examples that I have experienced. So if we need to these examples, I could give you a more in-depth explanations of these cases. Okay. So number one, as I mentioned to you, and as I highlighted to you, soils are natural materials, so that we have to make sure that whatever we do in the design, we have to follow what the most likely geotechnical conditions. Okay. For example, this is a real case. It happened like maybe 20 years ago. Yeah, about 20 years ago. Yeah, this is what I found in the design document. Okay, this is a typical slope stability analysis. Yeah, I'm sure that you guys are familiar with this. Yeah, okay, this is the model, and you have the minimum factor of safety, things like that. Yeah, as usual. Yeah, so there is a short-term factor of safety, the long-term factor of safety. Okay, everything looks okay. This is the typical thing that we find in design document. Okay, and again, you have learned about the use of software like Slope W. Yeah, you have learned to use that, and so you you could appreciate what I'm talking about. Okay, and one day there was a failure. Yeah, the slope failed, and after in-depth investigations about what happened, we now then understood. We then understood that, well, this is what happened. The geotechnical layers was not flat, was not level. The geotechnical layers were inclined. Okay, so if we compare, the geotechnical design assumes the soil layers were horizontal, were flat, were level. In reality, the geotechnical layers were inclined. Okay, it seems very simple, but in some cases, that could lead to failure. So when you do modeling, you have to make sure that you really model what is in the field. Okay, you cannot just take it whatever model I would develop. No, you have to be very, very careful about the details of the models. Otherwise, your design, it doesn't represent the reality. And that could lead to failure. You need to be very, very careful when you develop your models. Okay? Whatever model that you use, whether the slope W or the slope stability software or the more advanced software like Plaxis or Midas or whatever, finite element models, you need to be careful. You have to make sure that your design or your design calculations match with the reality. Otherwise, I don't know if you are familiar with the term garbage in, garbage out. The computer model could give you results from whatever you do in the model, but the results are useless when the models are not correct. Okay, So you have to make sure, yeah, that the models, yeah, in the design phase, yeah, match the reality, yeah, to so that you have quite good confidence, yeah, about what's going to happen in the field. Again, you need to then observe what's going on in the field. In this case, yeah, unfortunately, yeah, then uh, the the field embankment, yeah, collapsed. So again, this is the design issue, the first design issue that I would like to bring up. Yeah, this is what happened in the field. Yeah, it doesn't seem much. Yeah, but if you look at the field, if you look in the field, yeah, there are some observations that you could make. Yeah, in this case, you see a drainage ditch. Yeah, it's a ditch, a U ditch, and you could see that the the ditch, yeah, broke. Yeah. Why it broke? Yeah, that should be your observation point. Well, that, yeah, it, and obviously, yeah, the contractor didn't do that. Okay, there's no way that the contractor constructed this, yeah, just like this, a broken one. It's absolutely impossible, because otherwise the construction management would reject that. Okay, so this means that the broken, yeah, drainage ditch, yeah, happen, yeah, after the construction phase. And this, if you look at this, if you see a broken linear things, yeah, it means that there is a soil movement. And soil movement is a representation of slope instability. Okay, so there are things that you could observe in the field, yeah, uh, to to give you ideas what happened in the field, and that should warn you, yeah, about what is going on in the field. Yeah, this is the first thing that we need, the to highlight, yeah, what I've said previously. The second one is the whether we assume the design conditions and the appropriate design conditions or design modes. Okay, sorry, I just give you this example. Yeah, this happened maybe 10, 15 years ago. Yeah, during a construction of a major highway project. And if you look at this, do you notice anything strange in this picture? Yeah, just take a look for a second. Yeah, if you notice something strange about this picture, okay, and if you don't notice, I will just tell you. Yeah, if you look at this, if you look at these piers and you compare it to the next one, yeah, you could see the piers on the right, it's at a different angle, yeah, compared to the pier on the left side. Also, if you compare this pier, yeah, with the piers far away, yeah, you could see, yeah, these two piers are not in the uh, right angle, yeah, or vertical angle, yeah, compared to the other piers. So why the piers are not vertical? Yeah, and during investigations, what we found is that, okay, these piers, yeah, were on slopes, the slope, okay, and we found that the foundations of these piers, the P6, yeah, was designed, yeah, assuming that the soil was flat. Yeah. So there is no slope, yeah, assumed in the design. So This is the basic assumption, which is typical for designing, yeah, bridge piers. Okay, but then we need to remember this is a slope, so you cannot design the foundation as if it were on flat ground. You need to consider the slope, yeah, especially when there is high sliding risk. You need to combine, yeah, this modeling. So again, you have to model things in accordance to the reality. You cannot just uh, do whatever you think the right way in the model, but you just ignore the reality as a whole. Okay, in this case, and then the piers, yeah, move, yeah, because of the slope failing. Yeah, why the piers then not at a vertical angle? Yeah, because the pier, the foundation has moved. Yeah, if we look at this picture, these drawings, yeah, there is two for P6. Yeah, the ones with the foundations, yeah, it's not at the right angle. Yeah, relative to the design position. And if you look at the more detailed, the foundation moved about 8 meters, yeah, due to the slope instability, due to the ground movement of the slope. Yeah. That's why the pier were not vertical, yeah, because it moved for about 8 meters. So it is very important again to think through, yeah, the actual ground conditions. Okay, as I mentioned to you in the first case, the inclination, yeah, in the second place, the interaction between the slope and the foundations. Yeah, you have to think through when you are dealing with geostructures. What is the actual conditions? Do I model these actual conditions properly? Do I have to change the models, yeah, so that the models are representing the actual conditions? These questions are questions that you need to ask yourself. Okay, again, because soils are natural material. Yeah, you cannot expect the soils to follow your assumption. It will not happen. Okay, so the the soils have to be modeled as it is found in the field. Okay, so these two examples, yeah, uh, highlighted what has been highlighted before. Okay, okay. Number three, this is number 3A, and about number three is about you need to consider what's around the geotechnical structures that you're gonna build. Yeah. Otherwise, you're gonna have problems. Okay. And sometimes we just think about our project. We don't care about our surroundings. We don't care about the neighbors. We cannot do that. In upper structures, yeah, for buildings, for bridges, yeah, most likely your concrete or steel structures will not, yeah, affect other structures nearby. But that is not the case when you are dealing with geotechnical structures, because our soil, the soil in our project is connected to the soil surrounding us. Yeah? So you need to consider whatever surrounds us. Okay, we cannot just think about our project. We need to consider the neighbors, the surrounding areas, to make sure that your construction will not affect your neighbors too much. Okay, you need to be very careful about that. Always think about our neighbors. Always think about our whatever exist in our surroundings. Okay. This is an example, actually very simple project. This project is about road rehabilitation. Yeah, it should not be a very difficult project. Basically, to rehabilitate the road, you need to add some fill materials. Okay, the contractor did it already, and they did actually a very good job. And they contacted us, actually, the soil mechanics laboratory in Depok. If you could see, I signed the report actually, and we tested, yeah, the soil, the additional fill materials, and they passed. The contractor did a good job based on the scope of the work in the contract. And one day, the road collapsed. Okay, the scope of work of the project is just road rehabilitation. The contractor just need to put additional fill materials and the new rigid pavement, things like that. Yeah, but one day, the road collapsed. Yeah, why the road collapsed? And then the investigations revealed that there was wall and fill collapse beneath the additional fill. Okay, so did the contractor do something wrong? Yeah, the contractor just did whatever they are supposed to do. They just followed the contract, add fill materials, and do the rigid pavement after that. They did it according to the contract. So the people who wrote the contract didn't realize, yeah, there was a wall and soft soil beneath the road. So, and the factor of safety of the original condition is quite low. So because the contractor add some fill materials, the whole thing just collapsed. So although it seemed it was a very simple project to just road rehabilitation, it led to major, yeah, problem. It's a major crisis because this happened in a very busy road in Jakarta. Yeah, it happened in near Ancol actually. Yeah, I think all of you know Ancol, where Ancol is, right? And the road just collapsed, just like that. Okay, so did the contractor? I ask this question again: did the contractor do a wrong thing? They just did whatever they are supposed to do according to the contract. But the people who prepared the contract, prepared the design, didn't think through, yeah, that whatever they asked the contractor to do would lead to this collapse. So again, you need to think not only the project in a very narrow sense, you need to think about the wider implication of your project. Because again, when you are dealing with geotechnical engineering, you cannot just limit yourself to your project locations. You need to think about the surroundings. You need to think about the existing structures around you. Yeah, otherwise, yeah, that could lead you to problems. Okay, jadi yeah, so it is a very simple project, but it led to major crisis in Jakarta at that time. Yeah, because it's a very busy road. It's a very important road connecting busy the business district to Tanjung Priok Port, yeah, Port of Tanjung Priok. At the end, yeah, they had to rebuild the street, of course, and then they had to use driven piles, and they had to use pile-supported concrete slabs, and the project changed completely from a very simple road rehabilitations to major crisis and to the rebuild of the road using a much more expensive, yeah, design choices. Okay, so again, you need to be very careful, yeah, about what you are dealing with. You need to think about your surroundings. You need to think about are uh, what exists, yeah, in the surrounding areas. Okay. Just again, this is to give ideas that you need to be think. Yeah, you have to think through about what's around your project and when you're dealing with geotechnical engineering structures. This is another one. I just put it 3B. Okay. Again, uh, this is actually really a tragedy. Yeah, a real tragedy. Uh, this is actually a simple, yeah, basement excavation. Yeah. Relatively simple basement excavation is just one basement level, yeah, for parking purposes. And because of the geotechnical conditions, in which the groundwater level was quite shallow, the contractor had to do groundwater pumping. They had to do dewatering of the excavation. Okay. And what happened was, yeah, when you do groundwater pumping, when you do groundwater dewatering, yeah, you would affect not only your project but the surrounding areas. And in this case, that led to a tragedy actually. Okay. In this case, yeah, 4 people died in this exact case. And why there were 4 people died in this case? Yeah, I don't want to make scare you, but if you look at the right-hand side photo, yeah, the water was kind of red. Yeah, yeah, that was the part of the tragedy. Okay, uh, what happened was, yeah, the neighbor had a brick wall, yeah, for the fence of the property limit. Okay, so the neighbor had that brick wall, and the brick wall collapsed during the construction of the neighboring basement excavation. And unfortunately, the wall collapsed to the excavation site. And there were 4 people working, yeah, doing the excavation work. And the wall collapsed suddenly on top of those 4 people. And then that's why there were 4 people died instantly in that project, yeah, because of the collapse of the brick wall. And then we did a investigation. Yeah, why the wall collapsed? Yeah, it turned out it's about the basement groundwater control during basement excavation. If you look at the wall of the basement, yeah, you could see vertical, yeah, concrete piles. Okay, so these concrete piles were supposed to be the retaining structures. And we actually asked the contractor why you did that, why you used that kind of retaining structures. Yeah. These are so-called soldier piles. These piles with a certain distance. Yeah. And between the piles, there was just only soil. There's nothing else, soil. Okay. And the contractor mentioned, well, it was not in the design contract actually, not the construction contract. We just add that those piles, yeah, because we are worried, yeah, about the stability of the excavation. So we understood then the design was not complete. Okay? And the contractor had the initiative, yeah, to install these soldier piles and to protect the excavation. But their initiative was not good enough. Yeah. Why? Because they just use soldier piles. Yeah? And the water, the groundwater, could flow into the excavation site from the neighboring site through the soil in between the piles. That's why there was problem with the ground level, groundwater, and that caused the wall to incline. And ultimately, the wall collapsed, on top of these four workers, the construction workers. And unfortunately, those four people died. So, and we actually investigate further. Did you get permit for this construction? Yes, the contractor mentioned. Yeah, we got the permit from the city. Oh, okay. You get the permit from the city. Who signed the permit? Yeah, we went through all the administrative documents, and the permit was fine. So the contractor got the permit. The contractor had the initiative to add soldier piles to stabilize the basement excavation, but still it collapsed, because of the improper choice of returning structures, and ultimately four people died. So where is the so who how can I put it? So what went wrong here? The design was not complete. The authority gave the permit. Yeah. The contractor didn't really observe what happened to the neighbors. Yeah. So everything what could go wrong, went wrong at this project. Yeah, and then that's really a problem. Yeah. And again, as I mentioned, four people died in this project. So sorry. So so it is very important again to think through what you are facing. Okay, you have in this part. This is in I could tell you this is in Semarang, in Central Java. And if you come from Semarang, probably you know in the northern Semarang, the soil is very soft. Right? Excavation in very soft soil, very shallow groundwater table. You have very close neighbors. Yeah? Those are the surrounding conditions that you need to consider, when you deal with the design. If you work for the authorities, you need to think about that as well. You cannot just give permits. Just okay, this is just the usual practice. No, you need to think through when you give permits. Are these designs proper? Are these designs uh, or this doesn't have consider all the possible conditions? Yeah. Again, when you are working for the authorities, you need to think about that as well. Not only when you are in the consultant positions or the owner positions or the contractor position, even when you are in the authorities position, you need to think about that. Because in this project, yeah, the permit was issued by the local governments, the authorities. So all the stakeholders need to think about the whole thing. Yeah, you cannot just take it. This is just a simple excavation. Just do whatever we can do. Okay, you need to think through, about different things, to make sure that your geotechnical engineering structures would be constructed as safely. Okay. So this is a very unfortunate case. Yeah. But again, the contractor actually took the initiative, to install soldier piles, but that was not enough, to prevent failure. Okay. So the scope of work in the contract for the contractor was not actually complete. Okay. And so was the consultant at fault? Probably yes. Was the authorities have some part in it? Probably yes. Yeah, but it is very difficult because these parties, are then try to blame each other, as I mentioned by Professor Terzaghi, yeah, 80 years ago or 70 years ago. The blame game starts. Okay, and this is something that we don't want to happen. Okay, yes, we need to be very careful, yeah, since the beginning of the project. Yeah, again, this is to highlight, yeah, the importance of, yeah, construction phase in geotechnical engineering. Okay, anything to discuss or ask? Please feel free, yeah, if you have something in your mind. Okay. Okay, and this is the last in the last design example that I will give you. Yeah. The constructability issue. Whether what you when you as in let's say in the consultant position, you need to ask yourself, okay, whether now okay, this is could be constructed. Yeah, that what constructability is all about. Whether your design could be constructed. Okay, I'll just give you an example. This case was in Jakarta as well. Yeah, in if you are a train user, yeah, you probably know Stasiun Jakarta Kota. Okay, this is just in front of Stasiun Jakarta Kota. Okay, and the soil was very soft clay in the upper layer. This is typical in northern part of Jakarta. Okay, and the project was about, yeah, almost 20 years ago. Yeah. But if you look at if you go to Stasiun Jakarta Kota and you walk across the station, you could see the an underground uh, place. Yeah, this is about that. Okay, so the soil was very soft, and the design consultant just came up with this. Okay, we need to make an underground space, yeah, a space below the current surface level, and just do open cut construction method. Okay, that is actually what's in the design. Yeah, and the contractor, yeah, bid based on that. Yeah, so the contractor signed the contract based on, okay, it's very simple open cut construction method. The contractor just didn't think about the difficulties that they would face after that. And yeah, the reality is this is a very, very busy urban area. Yeah, if you look at this on the right side, you can see Stasiun Jakarta Kota. At that point, there was no underground space yet, and you could see that this area is very busy with cars and buses and all those things. And you could see there was uh, 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 Transjakarta stop. Yeah, yeah, the one with you're doing with the project. Yeah, so it was a very busy area. So how could you do this? So the question became, can we do open cut construction in a very busy urban area in a very soft place in upper layers? And the answer was quite quick, actually. No, you cannot do that. When you have very soft place, it is unlikely you could do open cut construction. Why? The slope will collapse immediately. And when you have that in very busy urban area, and that would create a major crisis. Okay, so the design proposed by the consultant was really improper. Yeah, the design, the designers didn't think through about these three components: very busy urban area, very soft play, and open cut construction. These things, yeah, cannot be done in one interlinked, yeah, system. So after very long discussions and things like that, and they actually had to change the construction method. They changed completely, yeah, from open cut constructions to sheet pile wall and ground anchors. So the construction cost, yeah, increased significantly. Yeah. The construction method had to change significantly from very cheap open cut construction method to very expensive sheet pile wall and ground anchors construction method. So the the contractor had to negotiate with the owner, in this case, the government of Jakarta. Yeah, the contractor didn't realize. Yeah, I just bid based on what I was given from the design document. Did the contractor do something wrong? Yeah, probably yes. They didn't think through, yeah, about the conditions when they do the bidding. Okay, did the consultant do something wrong? Definitely. Okay, because they just didn't consider many different things when they proposed the design. And this is to give you ideas. You need to be very careful. You have to use your critical thinking skill, yeah, when you are dealing with geotechnical engineering structure. You need to understand what the implication of the design and things like that. Yeah. When you do the design and the construction, yeah, and especially during the construction, yeah, related to this course, yeah, to make sure, yeah, the construction would be done, yeah, in a safe way, yeah, because when, let's say, the contractor just followed the design, yeah, I would guarantee that the slope would collapse immediately because of the soft soil, because of the very busy road. Yeah. But then again, the contractor had to negotiate the whole thing, yeah, because they had to change the construction method, yeah, uh, to ensure that they could proceed with the construction in a safe way. Okay, so these 4 or 5 examples, yeah, to give you real world problems, yeah, that I experienced, and I had the first-hand experience, so I could give you the details. Okay, and for this example, for the last example, again, this was a project by the government of Jakarta, meaning the authorities had the the contractor the permission to do the construction, but the authorities just didn't have enough capacity to understand what the implication of this design by the consultant. So hopefully, wherever you work in the future, whether you're in the government, whether you're in a contractor, in a consultant, or in a construction management, wherever you work, yeah, and you need to think this very thoroughly about your neighbors, about the actual ground conditions, yeah, yeah, whether the construction could proceed, yeah, as designed, or you have to change design, yeah, to ensure that. And as mentioned in or highlighted in previous discussion, you need to make sure that the communications among parties are well established to make sure that the you know, the construction, yeah, would be performed, yeah, in effective and safely way. So these are the things that I want to and convey to you, the narrative that I need to convey to you, why we propose this course, the geotechnical construction method, not only to learn about different construction methods, but to highlight the importance of construction phase during in the life project life cycle. Okay, and as I mentioned, as you submitted, you have touched upon the case studies, forensic studies to give you ideas. If you don't do projects, construction projects uh, uh, carefully, uh, that could lead to problems, in the construction site. Okay, any questions or any things to discuss? Okay, if there's no specific points to discuss, that would be fine as well. So just to repeat myself, so next week, hopefully we could do the class offline, not via uh, not via any online platform. So we could meet personally next week. That is the plan as of this time on Thursday. And I think it's in at 4 p.m. So hopefully we could meet in person next week. And please check your mask too. I will upload the assignment. I have uploaded the assignment for next week. Actually, you have some reading assignments as well for next week. Okay, please upload. Please submit your homework. And you have who you haven't done submitting your essay number 2 from last week. Please do so. Because again, this class is about your it's about widening your horizon. So reading is very important. So please read and write your essay and upload. Although it is already late, I will still give you grades although you are late in submitting the essay number 2. Okay, if there is no other things to discuss, I'm gonna end this class. Okay, I'll see you next